Hey, this is the IEEE EMBS podcast. You're listening to the episode 2 of The Rise of Genetically Enhanced Humans. I'm Sarvajith and this is my friend Ishwarya. Previously, we understood what human enhancement means, and while the brain has been an important character in our story so far, we see that there are a million other things that drive the plot forward.
Exactly. A remarkable milestone in this journey has been the effort to manufacture synthetic blood. Yes, you heard that right. Blood could be engineered to clot much faster than natural human blood, for instance, preventing people from bleeding to death. Synthetic white blood cells also could potentially be programmed. Indeed, like virtually any computer, these cells would receive software updates that would allow them to fight a variety of threats such as a new infection or even a specific kind of cancer.
It's also possible that enhanced blood will be genetically engineered rather than synthetically made. Regardless of how it is made, one obvious role for enhanced or smart blood would be to increase the amount of oxygen a hemoglobin can carry. Substantially more oxygen in the blood could have many uses beyond the obvious benefits for athletes. Prevent you from having a heart attack and give you a lot more energy for cognitive functions. Moving on, how do you think CRISPR will contribute to advancing this?
With CRISPR, what we're looking at is germline editing. The logic is simple. Alter the gene lines in an embryo's 8 or 16 cell stage, and that change will occur in each of the resulting person's trillions of cells, not to mention in the cells of their descendants as well.
In relation to cognition, we see that scientists have already identified certain areas in human DNA that seem to control our cognitive functions. In theory, someone's smart genes could be manipulated to work better.
In spite of this optimism, some scientists maintain that it will probably be a long time before we can bioengineer a substantially smarter person. This may be because intelligence on the whole may be dependent on the subtle dance of thousands of genes, which makes bioengineering a genius much harder.
So what does the future hold for us? Where is the world headed presently? Having more energy or even more intelligence or stamina is not the end point of enhancement project. Some futurists talk about the use of machines not only to dramatically increase physical and cognitive abilities, but to fundamentally change the trajectory of human life and experience.
For instance, some predict that by the 2040s, people will upload their brains into the cloud, living in various virtual worlds and even avoiding aging and evading dangerous synthetic pathogens and eventually death. Meanwhile, they also envision something called a whole-body prosthetic, which along with our uploaded consciousness, will act as a backup or a copy of us in case we die.
We are on the cusp of an era when human beings will be able to direct their own evolution. Our ability to select embryos during in vitro fertilization will grow over the coming years. We'll deploy gene editing tools far more precise than today's CRISPR systems to make heritable genetic changes to our future offspring. Over the coming decades, Darwin's original concept of random mutation and natural selection will gradually give way to a process that is far more self-guided than anything Darwin could have imagined.
While all of this may sound like things straight out of your favorite sci-fi novel, it'll take really long for this to be actualized. Genetic technologies touch the source code of what it means to be human and must be regulated. This job is all the more difficult because the technology is racing forward faster than the governance structures around them can keep up.
If and when it becomes possible for some parents to give their children enhanced IQs, lifespans, and resistance to disease, we will have to ask what this means for everyone else. Some will see these parents as first adopters paving the way for everyone else, like the first privileged people buying smartphones. Too few regulations could lead to a dangerous genetic engineering arms race. This is a fact we know, thanks to the doctors of Nazi Germany and their experiments, but trying to ban genetic manipulations would increasingly require the trappings of the most oppressive police states.
Clearly, this is a tightrope to be walking on. And there's a lot of thinking that needs to be done on the part of scientific professionals, bioethicists, and governments all over the world. It is, however, super interesting to think of a world where we could be resistant to diseases and more creative by birth. This is the thought we'd like to leave you with. Given a choice to enhance your future generations, would you take it? How do you feel about enhancement and what it could do to the human race? Write to us and let us know. Thank you for your time. You're listening to the SSN IEEE EMBS podcast. This is Ishwarya and Sarvajith signing off.